Alright, hello everybody, welcome back. This is part 8. In this video you're going to see me struggling to do some of the metal work. So we bought some blank chassis from Mojotone. Even though I've built a bunch of amps in the past, this is actually the first time I'm starting with a blank chassis, which is a little daunting. I tend to just figure things out as I go instead of like neatly planning them out in a CAD and having everything placed exactly where it needs to be. So with the first chassis, I sort of did a dry fit, found out where the transformer should go, where the board's going to go, and then I kind of made templates just on computer paper of where those holes get punched. And then I transferred that to all the other chassis. And now I'm sort of near the finish line. I'm doing the final holes for the tube sockets. So there's 4 of those preamp tubes that are 12AX7s, and then all of these are 50 watt amps. So there's going to be 2 power tubes that are the octal sockets. So yeah, doing some cutting here. I was using an old shop vac that was just, it always annoyed me because it was super loud. Later in the video you'll see that I upgraded, got a new one. It's bigger, badder, and better, but it's 50% quieter, or so they say. So here I'm measuring out, trying to get the center line from where those preamp tubes are going to go. I'll just mark everything with pencil or a Sharpie and then try and get things punched as cleanly as I can. I'm definitely not a machinist, so even the amount of time I do setting up to get, you know, a good center line going, when I go to drill it, I'll often be off that mark. You'll see later in the video I try kind of a bunch of different methods. I've got a spade bit, a Forstner bit, and then some stepper bits. I don't even know if the spade and Forstner bit are intended for metal. I think these are just thin aluminum chassis. So even though I started with those probably weren't the best match. I ended up going with the stepper bit at the end. And then I have a manual deburring tool that if you're only doing 1 chassis, it's not so bad. You can kind of knock everything out, but for 5 chassis, it just wasn't cutting it. So I tried to use various stepper bits to sort of automatically deburr all the holes. The most difficult cut on all of these chassis is the power socket. So that one, instead of drilling holes, I used one of the little metal cut saws on the Dremel. It wasn't perfect, there was some overshoot, but at the end of the day it works out okay. First attempt, I tried to use my really cheap Amazon drill press, and because the drill bed can swivel left and right, it was actually pretty difficult to get it to align with the spade bit so that I wasn't going to chew into that drill bed. So I did a couple of the preamp holes with this spade bit, and then it just got totally, you know, chewed down, and it wasn't even going to work anymore. I made sure to get the best camera angle so you can't even see me drilling, it's just my hand. The one good thing about the spade bit is that it does leave a cleaner edge. Even though the center might not be perfect on that pilot hole, I found that when I did the spade bit I needed very little deburring. It was a pretty clean edge. So there's 3 of the preamp tube holes, and now we're just going to add that last one, in this case V0, V1. And you'll notice I'm just kind of winging it here. There's no clamps, I'm just holding it down with my hands. Definitely got lots of little nicks and scrapes on my hands from all the sharp metal edges, but so, and then we just do the same thing over and over again. For all 4 chassis. I've already got the 5th one sort of finished all the way through, so I have some type of roadmap. So there was V1, now we're doing V2. Trying to get rid of some of the shavings in between cuts. And just dry fitting as I go too with that PCB to make sure that I'm still lined up. Yeah, I think now I got kind of tired of doing the drill press, so I switched over to the hand drill. I wouldn't say it's easier, but I can flip the chassis over and just drill straight down instead of trying to, you know, clamp it to that drill press and get things squared up every single time so that it doesn't run through center. I tried the Forstner bit one time. It was horrible. It sort of went all over the place even though there was a pilot hole, so quickly switched away from that. And now I'm finally on the stepper bit where I can just incrementally widen that hole until I get to the right size. The stepper bit, although it's like the easiest in terms of cutting, it does leave a pretty nasty edge, so it needs the most in terms of deburring at the end of the cut. For the power tubes, I actually had to use a stepper bit. I didn't have anything else that was that wide that would do it in one cut. So you see me switching over to the big stepper bit and then cutting the power tube holes. Yeah, and I'm blocking a lot of these shots, but when I'm doing the hand drill, you need a lot of downward force, so I'm kind of just putting my elbow down into it. And since nothing is clamped down, that chassis wants to spin from the torque, so you kind of have to wedge it between two things that aren't going to move, one of which is my elbow and the other's that black base of the drill press. Otherwise that whole thing would just start spinning. What I'd love to do if I'm gonna start making my own chassis more and more, I'd probably get like a dedicated punch set. I think the main brand that people use there is Greenlee. So I didn't have footage of using the Dremel, but this is showing you kind of the fit for that IEC socket. I tried to tuck it into that corner as much as I could, and then the Dremel is just essentially 4 cuts coming down. I'm not the best at it, so there's definitely some overshoot. You can see I kind of go past the corners of that rectangle. But the bit on the Dremel is just one of the thin metal bits that you can lock on there. So that's the first pass of all the holes. I used a couple tools to get rid of some of the deburring. So the main one was actually one of the, I guess it's meant more for woodworking. It's sort of the chisel. A lot of those burrs will curl over the edge, so if you use a traditional bit to try and clean up the edge, it's not even making contact with them. So I'll use the chisel to just sort of scrape away and get those burrs out of there. So you'll notice I only have the back panels cut out. We're going to have 2 speaker jacks, an impedance selector for the 3 different taps on the output transformer, the 2 fuses, the high tension fuse and then the wall plug fuse, and then that IEC socket. So that's the entire back panel. The front panel, I don't have anything cut right now. I'm still not certain if I want to do the controls on the front panel. I know that sounds weird, but one idea I had was to essentially make a 5U front panel, so a nice big high front panel, and then with those custom bakelite knobs I made, those are so big that if I wanted to put it all on this chassis, I'm not sure it would fit. There's 6 knobs per amp. So coming out with a different layout that's evenly spaced on this 5U faceplate, essentially, I think that would be cooler for all the controls to be there, including like the power switch and like the power lamp and standby. So if that's the way I'm gonna do it, I'll probably just have 1 or 2 holes coming out of that chassis with all the wires, shielded wires probably, going up to that faceplate where everything kind of fans out and you've got a nice user interface for the guitar player, and everything's not kind of cramped together on a typical front panel. So the big reveal, I can now pull off the just the protective coating on all these chassis to kind of see what the damage is. They didn't turn out that bad. I'm definitely not a machinist, so there's a couple things that are a little rough, a couple things that aren't perfectly lined up. We'll see how bad the damage is when we start putting in the PCB and seeing if things don't line up perfectly. But towards the end of this video, I'll show you kind of like a mock-up what it looks like when you've got the power transformer, the choke, and the output transformer all mounted down. But I am glad I kept the protective coating on there because it kind of keeps the finish looking more professional than scraped up during the drilling process. So here's all 4 of the chassis drilled to the best of my ability. And the next part is we're going to try and install the grommets. So coming out of the power transformer, the choke, and the output transformer, there are wires, our leads, right? And when we push those down through the chassis, we don't want those wires, even though they're insulated, we don't want them to make contact with the sharp metal edge of that hole. So the best thing to do in this case is to use a grommet, right? I've got this kind of grommet kit from Amazon. It's nice because they have a bunch of different sizes, but the quality of the rubber is really poor. This was like really, really hard, stiff rubber, almost as if it was already 20, 30 years old. I did try to heat a few of the grommets with like a heat gun, which is kind of a risky process. If you heat it too long, you'll get off-gassing, which smells horrible and probably isn't good for you. But yeah, so the next hardest part, other than the machining, is trying to fit all these grommets in just to protect the leads from getting scraped up by the metal. And you can see in the bottom left, chassis number 2, preamp tube number 1. That's the one spot where I tried that Forstner bit and it totally chewed up the edge. So that one doesn't look so great, but I'll try and clean it up later. So this is after I used a little bit of heat on those grommets, and now they're like way easier to install. So it's analogous to like a chewing gum type of feel, whereas before it was more like a jawbreaker. Didn't want to move at all. So now I'm just doing some light heat on the next batch of grommets, trying to get them softened up. Alright, with all the grommets installed, now we're going to start putting in some of the iron. So I'll start with the chokes. These chokes, they only have 2 wires, right? It's just acting like a big inductor. And this is to smooth that B+, the high voltage. The choke is in between the power and output transformer. I guess that's a little non-standard, but from the other video where I was testing essentially the magnetic coupling between the power transformer, 60 cycle hum, and the other iron, I found that when I put that choke in between the power and output transformer, I had even fewer coupling into that output transformer. So I think it's a good position to put that choke. It is still 90 degrees offset from the power transformer, but it's the same orientation as the output transformer. So we'll see if that actually cuts down on coupling when we get the first amp fired up. And now I'm putting on the output transformers, and those have the primary and secondary wires coming off of either side, so we've got 2 grommets for each of the output transformers. You'll notice too that the 3 transformers all in a row, they're essentially close to the front panel. So if I were to do controls on the front there, they'd probably be a bit too close to the power transformers. I wanted the tubes to be the first thing at the back panel so that it's just easier to service. You can see all the tubes right there. But in doing so on such a small chassis, I had to shove the transformers up towards the front. So this is just sort of another reason why maybe I don't put the controls up on that front panel there, and I'll just leave it empty for now. And the primary side of that output transformer is on the right. That's the red, white, and blue. So what goes to the output jacks is the other side, which is closer physically to that output jack and the impedance selector. Trying to keep all the wire leads as short as possible is always a good idea. The one thing I realized doing this, though, I ran out of screws, and then I quickly realized that these were the wrong screws to begin with. So I buy a lot of my parts from a website called ValveStorm. I've never had an issue with them. They usually have a bunch of stuff in stock, and the shipping's pretty reasonable. But essentially, for all the iron, I had the wrong components. I needed a beefier screw and a lock washer that had the kind of the rubber retaining part into it. So this is sort of the idea of what we're shooting for. There's the back panel with the 2 speaker jacks and impedance selector. We've got our 2 fuses and then our IEC. You can see on the IEC I have some Dremel overshoot on the edges there, so not the cleanest, but it's okay for now. And then that's the mounting of the transformers, right? So we've got things orthogonal to the power transformer, and then we've got all the holes cut for our tubes. But I do have the wrong hardware on the transformer, so I ordered the correct ones. I'll get that all swapped out in the next video. I can kind of show you where I would do that on ValveStorm too. So if you head over to ValveStorm and you scroll down, they have a hardware section, and this is going to be where you can find all the hardware for normal build, PCB standoffs, whatever you need. In this case, what I used to mount the transformers were these medium brass bolts. It's good hardware, but it's a little bit too small to support the weight of that transformer. So those are good for mounting other things like tube sockets or stuff like that. What I have on order and what I'll be swapping it out with are these beefier bolts. They're at least twice the thickness and diameter, and then they've got those bigger washers and lock nuts on there so things don't move around. He also sells grommets. Maybe they're better quality than the Amazon kit that I was using, but yeah. So thanks for checking out this video. We made a couple more steps of progress towards the end of our build. I'm hoping by end of February I'll have one of these amps ready to test, and I'm sure there'll be some issues that we'll have to hunt down, but yeah, hopefully we'll get some sound out of it. Thanks. See ya.